Okay, welcome to Super Breakout board number 2. I just put it on the bench, put the card in, and plugged it in. This comes up, and there's a note on this board right here. D3, D7, test bad, don't know why. And what that means is, I'll reset it. 0, 1, 2, 3, 4, 5, 6, 7. So D3 and D7 are failing. And this one I know is good because I put it in my other board that I just repaired. I took it out of that board, put it back in this board, and I know that RAM is good. So this is not a RAM problem that it's telling. This is misleading. So it could be an address problem. Addresses might not be getting through. Data, this is a I know there's a bidirectional buffering system in this somehow, because I seen it in the I seen it being talked about in the manual. It's a bidirectional data bus. So whatever that is, maybe there's 367s. I don't see a 245 on here. So there might be a couple 367s that are involved in buffering the data back to the CPU, or bidirectional. There's probably some special chip or something on here. I don't know. I really don't know. I'll have to look at it, look at the schematic and see what is bidirectionally buffering the data back. This one does not have ROMs. It has a couple banks of PROMs back here. But that's a promising start, to be honest. I like that it will go into test. That's nice. Should be easy. Should be a very easy fix on this. There looks like there's some work that was done here on the CPU that might be funky. The whoever wrote this note probably replaced these two RAMs and then wrote that note and said, I don't know why, they don't know why. It's in addressing or data path. It's really that simple. So we'll figure that out. I want to look at the schematic and see how. I know that the addresses are buffered out through these 08s over here in this area. I want to see how the data is bidirectional. Data bus is bidirectional. So let me do that. Let me look at the schematic in the CPU section and how data goes back and forth. Okay, one thing right off the bat, I just did a power test. This is the 5-volt rail right here, and it's coming up 4.56 volts. That is too low. This is going to have to be replaced for sure. So that'll be one thing to do, is replace that. That could be the whole problem. 4.5 volts is really low. TTL does not like 4.5 volts. So, and this thing's filthy. Look at that dirt. That is dirt. This is a dirt ball board. It's nasty. It's dingy looking. Yep. Okay. Might be a bad caps. The caps could be bad. 5-volt filter, there's one here. I think this filters the 5 volts coming in. Could be just bad caps. I think the first thing that I'm going to do with this board is wash it really good, and then I'm going to recap it, and then we'll revisit the power and see if changing the caps fixes the power. If it doesn't, then I'll have to replace this guy. Okay. Okay, I'm looking at the schematic here, and this is something that is interesting. This is the data coming out of the RAM, and it comes out. This guy right here, this 174 flip-flop, that's bits 3 and 7. Both bits that are failing are going through this 174. All the other bits are up here, that 174. So I'm curious to look at this 174 at L5 and see if it is working, because those are the two bits that are bad, that the test is saying is bad. So what I want to do is hook up to this guy right here. Pins 5 and 6 are the data coming in. Pins 12 and 15 are the outputs. So I want to see if the data is getting through this 174 properly. I guess first thing I should do is check where it's going through these inverters. So that's probably what I'll do first, is just probe these inverters here, and then that guy. Since it's those two bits that are bad, I bet you it's this 174. It's just too much of a coincidence that those two bits are bad, and they go through, those two bits only go through that flip-flop. So I'm going to check that guy. That's what I think is going to be bad. That's my guess. But I do want to look at these. But I suspect those will be fine. I think it's going to be that guy. So let's do that. Well, I came over to the board to look at L5, that 174 at L5, and someone already replaced it. So someone was thinking the same thing that I was thinking. But I'm going to pull that out and put it in my chip tester. So now I'm going to go back and look at the 04s, but I want to test that, and I want to check the work on this socket. But I think whoever had this board before me thought the same thing and saw those two bits going through this guy, replaced this, and it still didn't work. So I'll go back to the 04s, but I want to test that. Okay, as you can see, I got the analyzer out, and I'm analyzing the 04, and the two bits in question are input on 3 out to 4 and input on 5 out to 6. But we'll go through and we'll look at all of these. This is the first one. This is 1 out to 2, and it's fine, perfectly inverted. Now this next one is 3 out to 4. And this is one of those bits that is no good. And you can see that is not inverted correctly. It's not. That's no good. I don't even know if that data signal looks funky. Anyway, let's move on. And the next one was also in question. It's 5 out to 6. and it's kind of the same way. Looks like garbage. You can see there, it's supposed to be just an inverter. That ain't right. Let's move on. We'll jump over here to 9 out to 8. That doesn't even look right. That's not right either. And we'll jump over here. That looks good sometimes, and then it doesn't other times. And finally, this to this. And that just looks like a low out to high at all times. Okay. This chip is not doing what it's supposed to do, so I'm going to replace that 04. I'll do that, be right back. Okay, I'm going to take this opportunity to show how I clean boards. I have my mean green super strength cleaner here. I just spray it down with this. Really good. And then just take my toothbrush and go over it with the toothbrush. You'll be amazed at the dirt that comes off of this board. It's really dirty in here. I gotta be careful of this wire. It won't stick until I clean it. It will not stick to the board. The hot glue. Because I'll tack it down with hot glue, but it won't stick until I clean this board. I'm sorry if the camera's really shaky because I gotta hold the camera and do this at the same time. Just kind of go over the whole thing. I removed these ROMs. Not the ROMs, but the sockets. I removed those old Atari ROM sockets. Okay, now turn the water on hot. Just kind of turn the water on and watch all that dirt. Look at all that dirt. Get that dirt. Oh, here, that's too damn hot. Alright. Oh, that's still too hot. That's still too hot. Ouch! Cold. cold water, please. Okay. Look how nice and clean that board is. Look at that. Now always do the back too, because the back gets dirty. Believe it or not, it holds a lot of dirt. So just quickly go over the back. Get any loose, dirt that was loose or kind of in there good. Watch all this dirt off the back of the board. Okay. Turn the water off. Kind of let it drip dry as good as it's gonna. Okay. It's drip dry. Just kind of shake it a little bit. It doesn't need to be completely dry here. Now what I do is, normally I hold it and do this, but I'm filming so I can't hold it. I'll try to prop it up and take my alcohol and just spray it. Spray it good with alcohol. Get in the button good, get in the dip switch good. Just really, I gotta use my right arm here. Just really spray it good. Cover every little bit of it really good with alcohol. That will displace the water. It'll also clean the board from that water. Anything, impurities or whatever that are in that water will wash off with this alcohol. Alright, and then flip her over. Try to get it to stay. And do the back. Really good. That's pretty good. Just, like I said, that'll take about, just let that drip dry off of it as much as you can, and set it to the side. That'll take about 20 minutes and it'll be completely dry. 25 minutes or so. It'll be completely dry. That's how I do that. Okay, I've had to get the analyzer out again because I completely lost clock to the CPU. I got other clocks. I got sync's running, but pin 37 is the clock input to this for this thing to run, and it is right here. It's always low, stuck low. Now, what I'm looking at here with the schematic is this right here, this flip-flop. Clear is pull high, so it'll never clear. I am probing the 12 megahertz clock on pin 9 and the data coming into pin 3 and the output on pin 2. That's what I'm hooked up to. That's the beginning of this clock chain. And okay, right there I'm hooked up. Here's the 12 megahertz clock. This is the data coming in on pin 2 and pin 3 and the output on pin 2. And you can see data is high. So when that clock goes up, this should go up. And then that will start a chain reaction to the CPU. And then the theta clock will run, and the other two clocks that it generates will run, and it creates clock. This thing isn't doing anything. So I'm going to replace this 174. Alright. Okay, I got that 174 out of the board. And I just dropped the chip tester. And here it is. It says not found. It's no good. But yeah, this is okay. It's just the copper on the pad. I've already beeped it out because it looked like it pulled the pad, but it didn't. It's the copper on the pad there. So yeah, I'll put a new 174 in there, and hopefully we should have our clock back to the CPU. Okay, I replaced the 174, and I do got the clock back. This is the clock to the CPU, and we're back to this. So I disconnected the speaker because it was really annoying. So let me hook the speaker back up. Bear with me a second. Okay, nothing coming out of the speaker. Let's hook up to test. We'll probably get the same thing. We're at least back to that. Ooh, that's better. Is that this guy? It's different tone. That's bit 4. 2. Okay. 0, 1, 2, 3, 4. Okay, bit 4 now. That's good. It's changed to bit 4, which I think is this guy right here. Well, let's do what I did on the other one. I'm going to swap these two bits and see if I'm going to swap these two chips, flip them, and see if my beeps change to correspond to the change. Be right back. Okay, I swapped these two guys. So let's hit test. All right, this is a bad RAM. Apparently what was wrong with this board was the clocking was messed up. And it was this 174, which with me having it turned on for a certain amount of time, it finally just died. So I think now it's actually working correctly, and this RAM is no good. So I'm going to see if I can scrounge up another one of these RAMs. I'll probably just take one from the other board I already fixed, put it in here, just get the boards all working. You know, get the boards all working to where I can just, okay, I got my order of RAM in, so I'll pop one in here and that kind of thing. Okay, let me stick a new RAM in here and see what happens. Okay, as you can see, I took a RAM from one of the other boards and put it in here, and it's now doing the happy tone. Passes test. Let's take it out of test. Take it out of test, and it does not want to run. ROM bad. It says ROM bad. Oh, great. One of these ROMs are bad. One of these PROMs. Maybe I can just try to reseat them. I'm going to do that. I'm going to try to reseat these ROMs. I might have to trash these and put regular ROMs in it. Let me do that. Let me reseat these and see if it's just a bad connection. I can clearly say it says bad ROM. ROM something bad. So, alrighty. And I have no way of verifying these. These are not in MAME. So, hopefully it's just a seating issue. Let me try that. Okay, I can tell I have bad sockets. Watch this. It just reset, stopped. I have to replace these sockets. Yeah, I gotta replace these sockets. Alright, let me get to that. Okay, I removed everything from this section of the board, all the sockets, and I removed the two ROMs that were in the middle, that were soldered in. I carefully desoldered and removed those. I'm going to socket all of them. And I'm going to copy these files too, so that I have them and put them in the stash of Super Breakout ROM files. So if I ever need this version of the ROM set, I'll have them. Granted, they're good, but we'll see. So I'm gonna go ahead and solder in 18-pin sockets in here, copy those ROMs, and put it back together. Well, I had the idea of replacing the 8 PROM chips with 3 ROMs, and I was figuring they're probably 2716s or something of that ilk. Well, they are not. This is a chip I have never seen this pin out before. You got ground on pin 24 down there. Chip enables are on 14 and 24. And all these address and data bits are totally unique to anything I've ever seen, so I'm going to scratch that idea. I have to save these PROMs. Hopefully they're all good. I don't know what that is. I guess I could look through data sheets on bipolar ROMs. Anybody have any idea what this chip is? Please let me know. Got 10 new sockets soldered into the board. Yeah, there wasn't 8, there's 10 actually, because I pulled these two up that were not socketed originally, but I'm going to socket those. And you check the back. The idea is you'd never know that these were replaced by looking at the back of the board. Except for this. One pad came up. It was a pin that was folded over, and I had a hard time getting it up, and it actually pulled a pad up, unfortunately. But other than that, you would never know that these were replaced just by looking at this. No flux mess. I tell you should seek out a solder that is constructed with no clean flux. I believe the flux number on mine is 245. This is my solder that I use right here, and I wouldn't use anything else. That's what I use. Good clean solder does not leave a big mess. Okay. All right, well, I'm gonna get my cat off of my ROMs. You get out. Dang it. Okay. Alrighty, I'm gonna copy these ROMs. I already had to Frankenstein two of the legs on one of the chips. This one right here, I call this Frankensteining. I had to take chips off of a donor EEPROM that had already had legs busted off of it and solder them onto there. Like I said, I would have liked to have just put 3 sockets in here and used ROMs, but I have no idea what those are. That's a weird pinout. I've never seen that pinout before, so I'm gonna have to use these. Hopefully they're all good. Alrighty, I'm gonna copy those first, make files of them, put them away safe, and then pop them in the board. We'll fire it up and see what happens. Okay guys, I replaced all these sockets. I kind of cleaned the legs up as good as I could, put them back in. I just plugged it in, and there it is. It looks perfect. I'm going to put it into test again, and alright. That's the sound we want to hear, and then that says 00 on this, and when you move the thing, those two numbers move. I was kind of checking that out on the manual. Okay, there she is. And I did copy all of these files, so I now have a set of this ROM version. Which is nice. Okay. Well, I'm going to put this one aside until I get my control thing together. I've replaced the capacitors on this thing. It's got a good CPU socket. It's got a machine pin socket. And now we got solid connection on the ROMs. Alright. I'll put this one aside. I'll wait for my controller tester. Move on to the next board. One last thing with this board here. This dip switch is no good. I need to replace this dip switch, because you can see if I'm just pressing on that dip switch. See that? And right now it's supposed to be in English. Those top two ones being down right here, that's supposed to be English. If I took and pressed both of those down, which, let me see if I can accomplish that. Put one of these here, one of these here, and just kind of press down. It's in English. It's supposed to be that way. Now I take them up and it goes back to being goofy. So, and they did have that jumped with wires, jumping it on. I'm just going to replace the dip switch. And that'll fix that issue. Okay. Okay, got the new dip switch installed. And you can see it's in English with no, where's it at? Right here. No messy jumping wires around to make it work. Nice new dip switch. All good. Looking great. Okay, now I can put this one aside. I do want to replace this though to get that voltage closer to 5 volts, because it's at like 4.6. 4.6, I believe. Let me just verify that again. Five volt rail. Yeah, it's 5.54. That's just not good enough. It's not going to do it. So I am going to replace that, but I have to buy some, so I'm actually going to put in an order for some RAM and 82S131 proms. I don't have any, because I have to burn one of these for that other board. Excellent. Okay, I'll put this one aside. It's complete. It works. I just need to replace a few things on it. Well, replace that and then test the paddle. So I'll put this one aside and move on to the next.